Good morning, Math 30-2 students. Today we're going to actually look at lesson 1.4, which is the application of set theory. So after this lesson, you should be able to draw 3 circle Venn diagrams. You should be able to look at those words and, or not, and be able to fill them into the Venn diagram. You have to be able to identify errors, correct them, and then make sure that you are showing your work in the Venn diagrams. So example number 1, we have Shannon's High School starts a campaign to encourage students to use green transportation for traveling to and from school. At the end of the first semester, Shannon's class surveys 750 students in the school to see if the campaign is working. They obtain these results. So what I'd like to point out first is they're giving us 750 students right here. This represents your universal. So these are all the students that were surveyed. So when we create our Venn diagram, we're going to say U is equal to 750. So all the numbers in our Venn diagram circle should add up to 750 if we're doing this correctly. So let's read the rest of the information. We have 370 students use public transit. 100 students cycle and use public transit. 80 students walk and cycle, walk and use public transit. 35 students walk and cycle. 20 students walk, cycle, and use public transit. 445 students cycle or use public transit. 265 students walk or cycle. So what I want you guys to notice is the key words. So whenever you see the word and means the intersection between those circles. Or represents union. That means all those parts of the circle should add up to that number that they're giving you whenever you see the key word or. So in this case, cycling and public transit, those two circles should add up to 445. We have 3 sets in this example. So our 3 sets represent public transit, so that's 1 set. We have another set that represents cycling, and we have a 3rd set that represents walking. And then here in the bottom right corner, you would write the students that don't do any of these, that don't use green transportation. So we would want to include a number outside the circles, but still within the Venn diagram. With these 3 circle Venn diagrams, the hint is that you want to start from the middle. You want to start from the inside, right here, and work your way out. So if we read the information, this part right here represents 20 students walking, cycling, and use public transit. So that is the intersection between all 3 circles. They're actually giving us that the answer is 20. So this information is done now. So we have 20 students doing all. Now we're going to go up to the very top of the list. So we have 370 students use public transit. That means that this part of the circle, so I'll use numbers to kind of label it. So this represents what this number should be, this one should be, this one, and this one. So all the parts of public transit should add up to 370. So that's the blue dots that I put down. All those little spots should add up to 370. And in our case, we don't have enough information to find out each of those sections of the circle, so we have to leave that information for now. The next information we need is, it says 100 students cycle and use public transit. So 100 students cycle, that will be this circle right here. And use public transit. The keyword and means that we're looking at the intersection between those 2 circles. So that would be this part and this. This is the intersection between public transit and cycling. Okay, so we would put I'll put a little dot there so you guys see what I'm talking about. Now, since we already have 20, we know that since these two sections should add up to 100, we have to figure out what number should go here so that it adds up to 100 in total. So what I would have to do is I would have to go 100 minus 20, which is the intersection of all three, and that would give us 80. So what you should find is that those two numbers that we just placed in should add up to 100, and that means the intersection between both. And we'll continue with that same kind of model for the next one. So walking and using public transit. So walking and public transit would be this spot and this spot. So that's the entire intersection that is shared between walking and public transit. Those two numbers should add up to 80. As you can see, we already have 20. So to get this piece right here, we would have to go 80 minus 20, and that would give us 60 right here. So that's done right now. Now we have 35 students who walk and cycle. So 35 students should be the intersection between the two circles of walking and cycling. So those two should add up to 35. Again, we already have 20, so we're going to subtract 20 from there, and we're going to get that this piece right here is 15. As you can see, the intersection between them now adds up to 35. So that would be this dot right here and this dot right here. So we already filled out the intersection of all three. Now we're going to go on to the very top backup where it says 370 students use public transit. Remember how we said that all parts of the circle, the blues, should add up to 370. Since we have 3 of the 4 parts, we can now find out this piece right here. So in order to get that, we're going to take 370, we're going to subtract the 80, the 20, and the 60 that are part of that Venn diagram circle. So if we subtract 60, 20, and 80, you should get 210 right here. So that would be people that take public transit only. So now we have all these ones done. This is done, this is done, done, done. We've accounted for all of those. Our next step is we're going to go to the 445 students that cycle or use public transit. So what we want to know, we want to figure out and look at these two circles. So they're saying that this entire circle here, public transit, with, or is the same union, meaning in union with, cycling, all these numbers within the yellow should add up to 445. Now, we have every single number except for the students that cycle only to school. So we can use that 445 to find out this piece right here. So we're going to take 445 and we're going to subtract all the parts of the yellow circles that I just outlined. So we're going to subtract the 210. We're going to subtract the 80. We're going to subtract the 20 from it. We're going to subtract the 60 from it and the 15. So check that you have all the numbers. You should have 1, 2, 3, 4, 5 numbers that you are subtracting. And from all that, we should get that this is equal to 60 students for cycling only. So that's 60 students. So that is now done. Our last piece of information here that's given is 265 students walk or cycle. So I'm going to use, I'm going to use green to outline that for you guys. So walking or cycling would be, walking would be this entire circle, and cycling would be this entire circle. They should add up to 265 because of the keyword or. Or means union, that means add up all the numbers. As you can see, we have all the parts, all the pieces of the circles except for walking only. This one right here is the only one we're missing. To get this number, we're gonna have to take 265 and subtract the 80 from the green circle, the 60 from the green, the 20, the 15, and the other 60. So again, I'm subtracting 5 numbers. So what you should get is 30 right here. So what we're going to do right now is we're going to add up all these pieces together. It says how many students use green transportation for traveling to and from school. So that would be like saying the number of students that use public transit or cycle or walk. That would be all the parts of the circles. If you were to add up all these numbers that we filled in, 210 plus 80 plus 20 plus 60 plus 15 plus the other 60 plus 30, you should get that the answer is 475. So there are 475 students that are in this Venn diagram, in the circle part only. Okay, so in order to fill this Venn diagram out, we still need this part right here. We still need to find out the students that don't use green transportation. Well, this number comes from taking the universal 750 and subtracting all the parts of the circle, which is the union, 475. That will give you the students that aren't taking green transportation. So if we subtract those two numbers, you should get 275 students. So that's how we're going to fill in the rest of our Venn diagram, 275. Now as a check, you can always add up all the numbers within the circles and the 275, and it should add up to 750 if we did this properly. The last question we're going to answer is how many students use exactly one method of transportation? So exactly one. Those are the students that walk only, cycle only, and use public transit only. So walking only should be 30. So you would say 30. Cycling only would be 60. And public transit only would be 210. So what we're going to do is add up all these numbers. 30 plus 60 plus 210. And the answer should be 300. So we should have 300 students that use only one of these methods when getting to school. Okay, so this is a standard of excellence question. They're hard because there's 3 circles, there's a lot of information, and you have to look for keywords like and, or, and then use that to make sure you do subtractions properly and make sure everything adds up to your universal. Okay, so that's example number 1. Okay, so we're going to come back to this formula once we read the next question. I'll show you why this is an important formula and why we need it for the next question. So let's look at this example here, example number 2. So this is what they're giving us, the following clues. We have 28 students who have a dog, a cat, or a bird. We have 13 students that have a dog. We have 13 students that have a cat. 13 students have a bird. 4 students have only a dog and a cat. 3 children have only a dog and a bird. 2 children have only a cat and a bird. And this information I'm going to cross off because I find it's not really useful. But what we're missing here is the first question. It says, how many children have a cat, a dog, and a bird? If you guys remember our previous question that we did, in order to solve it, we started from the middle with 20. In this case, we don't have that. We don't have what the middle should add up to. So when we're drawing our Venn diagram, we still have 3 circles, because there's 3 sets. Our sets represent students that own a dog, students that own a cat, or I guess children here, and then we have the bird. In this case, what we're missing is the middle piece. We don't know what this is right here. In order to find that, we're going to actually use this long formula that we have here, okay? So I'll show you in a drawing what this actually stands for, which part of the diagram we're actually referring to. So I'm going to draw a big diagram to represent all of this. So we're going to start with this. Union means all the parts of the circles. So if I were to describe this as a visual, it would be me looking at all the numbers within these circles and adding them up. That's what union means. Okay? And what they're saying is that the union is equal to A. So if I have 3 circles, A would be me shading in just one of the circles fully. This would be A. Okay, so I'm going to outline it with the color you guys see. Plus, they want us to add up B. So if we have 3 circles, B would be this right here, me shading in all of this. Okay. Plus C. We have A, B, C. We would be coloring in, let's use purple. We'd be shading in all of this circle, including those overlaps there. Okay? But we're saying that if we were to add these up, we're counting areas twice. For example, this area is counted twice because it matches this area again. So we're not really getting everything shaded in once, we're getting this doubling. So we don't want that to happen. So we're going to have to subtract from this the intersection between A, B. So we're going to have to draw our 3 circles. And then we have A, B. The intersection between A and B would be this part right here. Okay, so we have to subtract that. So that's going to be in black. This part's the purple. This is our yellow. And then this was our red. So now we're going to have to subtract from that A intersecting with C, the intersection between A and C. So if we have 3 circles overlapping, what that means is we are subtracting A intersecting C would be right here. All that. And we still have to intersect, we still have to subtract the intersection between B, C. So let's use green for that. So we're going to subtract A, B, C. We're taking B intersecting with C, which is this part right here, and subtracting that portion. And finally, if you guys noticed, you see how we had over here, we had the intersection counted once, we had it counted twice, we had it counted a 3rd time, but then when we went to the next steps, we subtracted those 3 parts. Again, we subtracted the intersection 3 times, so we don't have the middle shaded. So in order to get the union, meaning all the parts colored in only once, we still have at the very end add the intersection between all 3 sections. So our last step is to add in the intersection of all 3, which is this guy right here. Okay, so if this is A, this is B, and this is C, we're adding in that, and that would add up to our union. So I know that's a lot, but we're going to apply that right now. So we need to remember this formula that we add all of A, all of B, all of C. We're going to subtract the overlap between AB, subtract the overlap between AC, subtract the overlap BC, and then finally add the intersection of all three. So this is the formula that we're going to use to answer our next question. So whenever you are missing a middle section, which we are calling x, we can use that formula to help us. Okay, so what I'll do is I'll start by writing out that formula. Okay, so the number of A union B union C. Remember, union is not the same as the universal. That's just what the circle should add up to, not the whole rectangle. So keep that in mind. We have all of A has to be added with all of B, and then all of C as well. Then we're going to subtract in any order. A intersecting with B, subtract. A intersecting with C, and subtract the number of A intersecting with, actually it has to be B intersecting with C. B intersecting with C. And then we're going to add up all three, meaning the intersection of all three would be B intersecting with C, intersecting with A, all the parts, so all three parts. So this is the formula that we're using right now. So let's see what we have. Let's go back to the information. 28 children have a dog, a cat, or a bird. The keyword or means that they're asking us or they're giving us the union of all three. So that represents this number right here. We can write as 28. So we know that there's 28 total students that have these animals. Now, if they said 28 children were surveyed, we would not be able to use that number in this spot. We would actually have to subtract the number that usually goes outside of the Venn diagram to get that union. Our next part is, they see that 13 children have a dog. That means that the entire circle should add up to 13 right here. So that, we can say that this would be set A. If we were to use letters, we can say 13 represents how many have a dog, plus 13 have a cat. So we know that this whole circle should add up to 13, so that represents, in this case, B if we want to. What I'll do is I'll use the letters that they give us in the formula, and that way it'll make it easier for you guys to understand what I'm looking at. So I'll call this one A, and I'll represent it as dogs. I'll call this one B, and represent it as cats. And C will represent birds. Okay. So we know that this one should add up to 13, this one should add up to 13, and birds should add up to 13. So we have 13 that are birds. Now we're going to subtract the overlap of the entire thing. So there's another key word that we're going to have to watch for, guys. It says the word only right here. So this word only, before in the previous example, when we had 4 children have a dog and a cat, we would know that dog and cat would be both these parts, right? But because of the word only, it takes off the middle section between all three. They're telling you that these are the students that only have a dog and a cat, but they don't own a bird. So that number would go here, and we would not have to do a subtraction if you see the words only. So if you see the word only, no subtraction is needed. If you don't see the word only, you'll need to subtract that number and the x value that you would have. Okay, so we have 4 children have only a dog and a cat. We have 3 children have only a dog and a bird. So we have dog and bird would be 3. 2 children have a cat, only have a cat and a bird. So that would represent this number right here, 2. Okay. Now if you look at the formula is saying that they want the intersection between A, B. They want these 2 numbers put together. That's the intersection between A, B. So we're gonna have to subtract 4, and we're gonna have to also subtract x for us to get the intersection between A, B. We're gonna have to do that as well for the next set. So if they want the intersection of AC, we're gonna have to subtract these two numbers. Okay, so we're gonna have to subtract 3 and another x. And finally, in order to get the intersection between BC, we're gonna have to subtract 2 and subtract x as well. The last part of the formula, which is really important, is a lot of people forget that we still have to add the intersection of all 3, and in our case, that represents x. So we're gonna have to add this x. So this is an algebra equation that we're gonna have to solve. So my hint to you guys is when you're solving this, keep the 28 by itself right now. But what you're gonna do is you're gonna add up all the numbers in your calculator. You're gonna put all these guys together in your calculator. So you're gonna go 13 plus 13 plus 13. Then you're gonna subtract 4, subtract 3, subtract 2, and in your calculator, you should find that that is equal to 30. The next thing you're gonna do is you're gonna put the x's together. You're gonna say, well, I have negative x, negative x, negative x, and positive x. What's important to realize is that if you have a negative x and a positive x, they will cancel each other off. So I can cross off one set of negative x and positive x because they become 0. So all I have to do is put this x and this x together. So negative x and negative x will add together to give me negative 2x. So we're almost there. When it comes to algebra, what's important is we have to get the variable by itself. We have to get x alone. So what we're gonna do is we're gonna subtract 30 and bring it to the other side. That crosses off. 28 minus 30 will give us negative 2, and that's equal to negative 2x. Then we divide the number in front of x to both sides.
Good morning, staff. We have a favor to ask of you. If you are in the building, we're going to ask that you please just quickly email Danielle and tell her that you are here. We're not taking attendance. We're just planning some activities for Fun Friday. So please email Danielle if you're here so we can get a sense of how many people are in the building. Thank you.
Sorry, guys. Okay, so negative 2 divided by negative 2 gives us positive 1. Now we know what the middle should look like, and that helps us fill in the rest of the Venn diagram. So on my next screen, what I'm going to do is I'm going to fill in the Venn diagram to be able to answer all the questions. Okay, so it's a lot of work to get that middle piece, but once you get it, it helps you solve all the rest of the pieces. Okay, so in our last step, we're going to draw out those 3 circles again. I'm going to label A for dogs, B for cats, and C for birds. Now I'm going to start with the middle. Remember, we solved x and we found that it was 1, so I'm going to now place a 1 in that spot to help us. We already know that the students that own a dog and a cat only was 4. The students that own a cat and a bird only was 2. And the students that owned a dog and a bird only was 3. Now remember how these numbers were all adding up to 13, remember? So in our previous example, we had 13. But remember, 13 represents all the parts of that circle. So if I'm talking about dogs, all of this circle should add up to 13. So if I want to know what the students or the children that own dogs only, I would have to go 13 subtract 4, subtract 1, subtract 3. Over here for cats only, I would have to go 13 minus 4, this number right here, minus 1, minus 2 to get that. And finally, for cats, I would have to go 13 subtract 3, subtract 1, subtract 2. So don't forget to look at those circles and see what is in the circle and subtract them out. So for dogs only, you should have 5. For cats only, you should have 6. And for birds only, you should have 7. So our last check is we can add up all these numbers, but since we don't have the universal, there's no way to really check. So if you were given the universal, you could use that, but in this case, we don't. We'll just fix this. This should be a 6. Okay. And then let's answer the questions. Question A said, how many children have a cat, a dog, and a bird? Well, that would be the intersection of all 3. So we found that that was equal to 1 with that long formula that we use. That's called the inclusion-exclusion formula. So that's for 3 sets. For B, they want to know how many children have only 1 pet. So that would be this number here, this number here, this number here, added together. So that would be 5 plus 6 plus 7 added together, and that would give you 18 children have only 1 pet. Okay. And that is lesson 1.4. Hope you guys have a good day. Hopefully I see you guys soon.